In this video, we are going to learn about sampling theorem. Now, first let us go with the theory. Okay, sampling is the process of converting a continuous time signal x of t into a discrete time signal like x of n ts. Don't worry about this. Like we are converting into a discrete time signal x of n by taking values at regular intervals. Okay, by taking sample values at regular intervals. So this is from the theory. You need to take a small concept. Sampling is nothing but converting the continuous time signal x of t, like continuous time signal, to the discrete time signal x of n, or you can write x of n ts, means it is nothing but discrete time signal. Okay, I hope you got the idea. What is this ts means? This ts is by taking sample values at regular intervals. Ts is nothing but the sampling time period. Okay, you need to remember in this way. Now let us move into the sampling theorem. Sampling theorem is also known as the Nyquist theorem. Okay, it is in other words, in more technically, you can call it as a Nyquist theorem. Now, a continuous time signal can be reconstructed perfectly from its samples f of is greater than or equals to the 2fm. So when it perfectly reconstructed from its samples means with this condition, like f of s greater than equals to the 2fm, where f of s is a sampling frequency, f of m is highest frequency present in the signal, or in the given signal, highest frequency in the given signal. Ts is the, just now we discussed, sampling period. Okay, the quality of 2fm is called the Nyquist rate. Okay, we have few cases in the Nyquist theorem, like as follows. By seeing cases, from the case 1, perfect sampling. Perfect sampling happens when the sampling frequency is greater than the 2fm. Here, in the perfect sampling, the signal won't overlap, no overlapping, perfect reconstruction possible. Okay, now in the case 2, Nyquist sampling, or you can call minimum sampling. Okay, minimum sampling is f of s, fs, which is equals to the 2fm, which is the minimum sampling frequency. Now aliasing happens when f of s, fs less than the 2fm. Here spectral overlap occurs and original signal can't be recovered. Okay, this is the points you need to note. Perfect sampling is like fs greater than 2f is known as perfect sampling, and minimum sampling or Nyquist sampling is fs equals to the 2fm. Aliasing happens when fs less than the 2fm. It is a perfect, it is a Nyquist, and it is a aliasing. This is the 3 cases in this sampling. Okay, now first let us understand the sampling concept with the diagrammatical. Okay, when you fall into this diagrammatical, first our given signal obviously is f of m, like highest frequency in the given signal is in like this, let it be. This is in the continuous time signal. Now from this we are taking the fs, like f of s, which is like sampling frequency in this manner, sampling frequency in discrete manner. Okay, this is the samples. So when you combine these two things, you will get the resulted discrete time signal from the continuous time signal like this. So here this frequency, like sampling frequency, will changes according to the given frequency. Okay, like this it will be changed. See, this is how our things will be. This is known as the sampling. Now continuous time with the use of the discrete, it is converted to the discrete time signal. Okay, this discrete is known as the sampling. Okay, so in order to convert from CTS to the DTS, we need sampling. In the first question, given x of t is equals to the sine 2 pi t, sine 3 pi t, sine 4 pi t, find the minimum sampling frequency. Means we need to find the case 2 of the question. Case 2 is like f of s, which is equals like fs, which is equals to 2fm. Now first let us find the fm. Fm is the max frequency in this. So max frequency, directly from these terms we can state that this is the max frequency, right? So now let us go by the theoretical. So omega is obviously 2 pi here. This is sine omega t, right? Let here I given the detailed concept. You can check out here. Let sine omega t, compare this with the given terms. Let first term, okay, omega 2 pi. 2 pi, here omega is 2 pi, right? Here I am taking like omega is 2 pi, means omega we can write in terms of 2 pi f. So it is the first frequency, right? So that's why I am quoting with the f1, okay, 2 pi. Then f1 is obviously 1 hertz. So f1 is 1 hertz. From this you can state that omega is a 3 pi. Omega we, in terms of frequency, you can write like this, like 2 pi f2, 3 pi, pi will cancel, 3 by 2, which is like 1 by like 1.5 hertz. From this omega equals to 4 pi. Omega we can write like this, like 2 pi f3, okay, 4 pi. Now 2 pi, 4 pi, which is nothing but the 2 hertz. From this, what is the max frequency or highest frequency, which is the f3, right? 2 hertz. Fm is now f3, nothing but 2 hertz. Or directly you can ignore these two calculation. You can write from here by seeing only, you can say, right? Now apply the sampling theorem. Sampling theorem, f of s is greater than or equals to the 2fm. Fs greater than or equals to 2 in what is the fm? Fm is the 2 hertz. 2 into 2, 4. Fs greater than or equals to the 4 hertz is nothing but the sampling. Minimum sampling frequency fs, which is equals to the 4 hertz. Okay. Now let us go for the second question. In the second question, find the sampling frequency x of t. So for the sampling frequency, we need the highest frequency. Highest frequency contains in the cos, okay, like 200 pi t. You can do this thing here when you calculate. So omega we can write 2 pi f2, 200 pi. Now f2 is equals to 100 hertz. By these two terms, you can say that highest frequency fm, which is equals to the 100 hertz, and apply the sampling frequency fs greater than or equals to the 2fm, fs greater than or equals to the 300 f, where fm equals to the 100 hertz, right? So 100 into 2, 200 hertz. Therefore sampling frequency is 200 hertz minimum. Okay, I hope you got the idea on this about the sampling theorem. Now let us go the very depth in aliasing and with problems. Okay, now aliasing effect. First let us see the theory. Aliasing is a distortion effect that occurs when a continuous time signal is sampled at the rate less than the twice its highest frequency. Nothing but this is the thing, like fs when less than 2fm, then aliasing effect will occurs. Okay, when this happens, when sampling is low, too low, then the things occurs like spectral ripples overlap in the frequency domain. Okay, you need to remember this thing. Highest frequency components folded back into the lowest frequency. where highest frequency is folded back into the lowest frequency. Okay. So different signals look like the same after sampling. So after sampling, different signals are looking like the same because of this too low sampling. Okay, that fake low frequency appearance is called the aliasing. So now, so different signal look like the same after sampling, right? This is known as the fake low frequency appearance, right? This is called the aliasing. General example for this, you will get the picture here. Okay, a wheel rotating fast. Okay, if the camera frame rate is slow, then wheel appears to the rotating backward, right? This is known as a false motion aliasing. Like a rotating wheel is there. When you captured it, then this is the fast moving wheel. This is a low frame capturing camera. Then when you capturing this, instead of rotating like this, it may rotate in this manner in your video. This is known as a false motion, nothing but the aliasing effect. Okay, this is how our general example will be. Okay, let us jump into the questions. Now a signal has frequency x of t like sine 50 pi t. It's sampled at fs 30 Hz. Find LS frequency. Okay, FM is 20 like 50 pi by 2 pi, nothing but 25 Hz. Now the relation of F and Fs and 2FM is like 30 were given Fs and 50 we got 2FM, means obviously 30 is less than the 50, right? So where aliasing occurs. Okay, now we need to find the alias frequency. Alias frequency is like Fa. Let us denote the alias frequency as Fa. Fa is like the max frequency, max frequency minus the sample frequency. Max frequency is 25 we got, and minus 30. This is the bar. Either if you got plus or minus in this, you need to indicate by the plus only, right? This is the meaning of this thing, right? So Fa now we got as like 5 Hz. Now let us move for the second question. X of t is sine 2 pi 10t plus sine 2 pi 40t. This is the obviously max one, right? Like F2 is 40 Hz and FM we take F2 only, like 40 Hz. 2FM is 80 Hz. The relation of F and 2FM is like given FM is 60 Hz and 2FM we got as 80 Hz. Obviously 60 is less than the 80. Therefore Fs is less than the 2FM, means aliasing occurs. Now let us find the Fa alias frequency. Alias frequency is like Fa bar of max frequency F minus the sample frequency, like 40 minus 60, 20 Hz. So this is how the aliasing effect in sampling. I hope you got the idea on this. If you learned anything in this video, please do a like and support by subscribing. Thank you. Thanks for watching this.